Hi, so these are some quick video notes of how to calculate the specific heat of a substance using calorimetry. This question is from the Gizmo, question one of part C. So, the big idea of calculating the specific heat of a substance is we have to think of it as two systems. This statement right here that I highlighted is super important to understand what's going on. We'll get to that in a minute, but essentially, when you put a hot metal in cold water, the heat from the metal goes into the water. So, this is how we do the work. What we're going to do first is we're going to use Q equals MCAT for water. So I'm going to take and I'm going to look at the information that's given to me in the question. Everything about water. All right, so Q is our heat. That's what we're going to find. M is the mass of the water, which is going to be 1,000 grams. C is the specific heat of water. This is where students often get confused. So water has a known specific heat of 4.184 joules per gram degree Celsius. We could also do this in calories, but since the question is giving that number to us in joules, we're going to use that number. Make sure that you always use the number as given in the question. To avoid rounding errors. Okay? And then we're going to have the change in temperature again for water. So the change in temperature for water was 2 degrees Celsius. So I'm going to write 2 degrees Celsius. So in the formula, Q is what I'm looking for. M is the mass, 1,000 grams. C is the specific heat, 4.184 joules per gram per degree Celsius. And the change in temperature for water was 2 degrees Celsius. So essentially what you're going to do is you're going to take and you're going to multiply all those numbers together. Notice that grams cancels off, degrees Celsius cancels off, and you're going to be left with joules. Pause the video, do that calculation in your calculator before you see the answer. All right, so hopefully you pause the video. If not, pause it now, do your work, and then check. The correct answer that you're going to get for this, if you did everything correct in the calculator, is 8,368 joules. That is the heat that is absorbed by the water. Good. So that's check. That's part A. So we have to do that, and you're going to see why we have to do that in a minute. So for B, I'm going to go ahead and do the work in blue so you can see the work, how it's different. For part B, we're going to still do Q equals MCAT. The question is asking to solve for the specific heat of aluminum. So I'm going to use Q equals MCAT. But this time, it's going to be everything about aluminum, not water. Okay, so again, for aluminum. Going through the work. Q, M, C, delta T. The change in temperature for the water is 74.95 degrees Celsius. So that says negative 74.95, so I'm going to start with that. I'm going to change that in a minute, and I'll explain why, but for now, since that's the number they gave us, that's what number I'm going to use. The mass of the aluminum is 125 grams. The specific heat is what I'm looking for, and this is where students often get confused in this question. We're looking for the specific heat. We're not looking for the heat. We're looking for the specific heat. So the problem is we need to know what the heat is. Well, that's where the highlighted words come into play. Remember, the heat that was absorbed by the water is exactly the same heat that is released by the aluminum. So the amount that's released by the aluminum is 8,368 joules. To show that it's released, I really should put a negative number there, But what's going to end up happening is the energy was released, which caused, let me highlight that so the energy was released, which caused the temperature to go down. So to simplify our calculations, I'm always going to treat these as positive values. So the heat that was released was 8,368, and the temperature went down by 74.95 degrees Celsius, and that allows me to get rid of the negatives. You can leave the negatives in, but you just need to be consistent with your work. If you're going to do longer calculations, specifically if you're going to try and find the starting temperature or final temperature, you really need to pay attention to that. But other than that, generally don't. We're not going to deal with that in this class, so we're going to keep everything positive to try and keep our numbers a little bit more simple. Okay, so now, just like I did before, I'm going to plug these numbers in to Q equals MCAT. So I'm going to start with 8,368 joules, which is Q, equals my mass is 125 grams, M. Our C is what we're looking for, so I'm going to leave that as C. And our delta T, our change in temperature, was 74.95 degrees Celsius. All right. So where students struggle with this is this becomes now an algebra problem. I'm going to now solve for C. So when I'm solving for C, I want to get rid of the numbers that are next to it. So I can multiply them first and then divide, or I can divide them one at a time. I'm going to divide them one at a time to do this. If you're good at algebra or you're sort of remember your algebra, then pause the video, do the work yourself, and then check your back here in a moment once you're done to see if you did it right. If you're not good at algebra, I'm going to walk through right now how to do it. All right. So solving this. The first thing we're going to do to solve this, and I'm going to do this a long way, because it's going to kind of illustrate where we're at. I need to get rid of the 125 grams because that's next to C. So it says, algebra says, since I have 125 times C, I'm going to divide both sides by 125 grams. So my number is 8,368 divided by 125. On the left side, I'm going to write down the entire number. Now, this is a problem with this, is I want to write down the entire number. Don't round. So I have 66.944. The units are going to be right now joules over grams. This part over here cancels off. And on the right side, I still have C times 74.95 degrees Celsius. So I'm going to take that now, and I'm going to divide both sides by 74.95. Same idea. I'm getting rid of the thing that's next to the C. I'm getting rid of next to the variable that I want. So I need to get rid of that 74.95 degrees Celsius. So on the other side, I'm going to divide this whole thing by 74.95 degrees Celsius. That cancels off. So this looks a little bit confusing. But remember, it's still that number. I can think of it like this. It's still that number divided by what I have. Okay, so I'm going to take 66.944, and I'm going to divide that by 74.95. And I'm going to get on this side 0.893. Now I can round because I have my final answer. C is over here by itself. My units are going to be joules divided by grams times degrees Celsius. So another way to look at the units, if you're a little bit confused by that, is this grams per degree Celsius. Notice at the first, I could have multiplied those two numbers together and gotten grams degree Celsius and divided that number, that whatever that big number is on the side. Okay, so this is my final answer. This becomes the specific heat of my aluminum. So I could say that the specific heat of the aluminum is 0.893 joules per gram per degree Celsius. And I'm done. So quick recap. What we did first was we found the heat that was being exchanged by both substances. And we do that using water. That then allows us to find C for aluminum, knowing that that number is the same for both. We're using Q equals MCAT twice. First for water, the simple multiplication calculation, and then we use Q equals MCAT for the metal, in this case aluminum, and then we do algebra to solve. Hopefully this helps you.